Okay, so our second standard is transformations. That's FX for function. It's my abbreviation. All right. And we're going to, two definitions and then a little bit of notation here. A parent function is any given graph or equation. Right? I could give it to you as a picture on a coordinate plane, or I could give you an equation. Connected to the parent makes you think of a family of functions. A family of functions is a collection of, we'll say, graphs or equations that includes the parent and all possible transformations. All right, I know you're in algebra, but you cannot forget the things you learned in geometry. Does anybody remember the vocabulary words that you used in geometry to describe transformations? One of them. Translation. Okay, yes, translation. Yep, well, let's put that one down. Translation. How did translations affect the picture? They slid it left, right, up, down, right? Okay, so left, right, up, down. Okay, yes, right here. Rotation. Okay, I'm going to put rotation over here to the side because we don't actually rotate this year, okay? But you can do a rotation. We're just not going to cover it. All right, any other words? Yes? Reflection, yes. Okay. Reflection. Now, how did you do that? Like, flipped, yes, or folded over some line, maybe the x-axis or the y-axis, or maybe did they do it over the origin? Maybe. Okay. So there's a couple ways to reflect it, but I like the word flip. I'm going to put flip or fold because you had to like fold it over something. Okay? And one more word. Yes?
Dilation.
Yes, dilation. Okay, what did dilation do to the pictures?
Made it
Bigger or smaller. Okay. Bigger, smaller, yeah, that's fine. Bigger or smaller. All right, guys, that's all we're going to do right now. That's it. We're going to go left, right, up, down, flip or fold, big or small. That's it. Except this is not geometry, and we are going to put function notation that goes with it. That's what we're going to add. You're going to do the same types of things to the pictures, except we're going to start with a function as opposed to like a parallelogram. We're going to start with a function graph, and then we're going to move it around. Maybe we make it bigger, maybe we make it smaller, maybe we flip or fold it. Okay? So our first notation is going to be f of x, and this is going to be our parent function or graph. I'm not going to start with the equation. I'm going to give you just a picture. And that's what leads us into your little Desmos slide. Okay? You're going to have eventually a x minus h plus k. So I am adding these three letters, A, H, K. You are going to click around in the little Desmos slide, and you're going to figure out what each of these letters does to the picture. But you're going to try to be specific about what happens. Okay? And then we'll come back and share what we have found. Ready? Okay, here you go. Let's go ahead. You can click into that link. Here it is. So here's your parent function. Notice that half of it is curved and half of it is straight on purpose. Okay, here's the parent function. Only move one slider at a time. Notice that I put the same function notation right here. Okay, move one at a time and see if you can predict or decide how that letter affects the graph. Go for it. Couple minutes and then we'll share. If you are in Blackboard, there should be a link in the 1.2 notes section. Right here. There you go. Yep. Okay, so go for it. Slide your K. What does it do? Think of those geometry words, right? How would you describe it to me? Right? You can always put it back to 0 and then move the next one. We're going to formalize it together. You can just kind of keep track for now. Yeah, you just click and drag your sliders to see what happens. Yeah, click and drag your sliders. It'll move the graph. You don't have to pick one word only. You can do multiple words for the letters. We're going to formalize it. You're just looking right now, and then I will write it. Make sure we have the right vocabulary. You can use more than one way to describe it, right? A might have more than one.
Well, if you zoom out, then it's not doing anything. Oh, yeah.
Oh, that's so weird.
Yeah, I think it's because it's silent. It's 0.
Oh, yeah.
Yeah, use the dilation because as you like,
oh, yeah.
It was actually just a horizontal line. Okay, let's start easy. Who wants to tell me what K does? Yes, Alyssa. K?
Up or down.
Up or down. Okay, so look at K. Notice how K is f of x. Add K. F of x is the y coordinate. Add to the y coordinate. So it goes up or it goes down. Up or down. It changes the y direction. Okay, H. H changes the x coordinate. Look at how the H is in the parentheses next to the x coordinate. It changes the x coordinate, which is right or left. Now, there is a negative built into this formula, so that's going to be a little bit interesting. Okay? All right? And A. Let's put these two back to 0. A. Any thoughts on A? Yes.
dilation.
Dilation. Yes. Do we have another word that goes with it also? No, you're good. Dilation. Something different. Reflection. Look at this A value. What if I do this? I'm just going to type so you can't see it. What did a negative A value do? Folded it over the x-axis. Reflected it over the x-axis. Oh, but it's also changing some other things. Okay, so notice right now that this, what's the slope on the right side of this graph? 1. Okay, look at the slope for a second. Because we need to be a little more specific about how the A value is dilating the graph. Right? We're increasing our knowledge from geometry. You will be doing more than what you just did last year. What's the slope on the right side of the graph? For the black one, the black graph. 2. So your slope went from 1 to 2. Interesting. Okay. See this point here? Okay, see this point here? Oops, sorry. There it is. What changed? The red point went from 2, 2 to 2, 4. Which coordinate changed? The y coordinate. A times f of x. So which coordinate is changing? The y coordinate. Okay, so let's do this. Let's just add a simpler version here. Okay, it's blue. I just want this. A times f of x. That is a times the y value. So let's do 3. If the y value used to be 2, what's it going to be now? 6. If the slope used to be up 1 over 1, what's the slope going to be now? Up 3 over 1. Is your slope changing y over changing x? You're only changing the y coordinate. Up 3 over 1. Look at that slope. It's a 3 over 1 now. Okay, so that's a line. Let's look at the curved part. Okay, let's look at the red graph. Let's scooch up here and look at this coordinate here. -2, 4. I'm trying to move it. It's really hard. Just barely. You'd think it'd be easier. Okay, that's close enough, guys. That's all I can do. All right. What if the A value is 3? Where should that dot be on the blue graph? The A value is 3. Where should the dot be on the blue graph? It's not on the screen on purpose. Where should it be? Which coordinate is changing? Changing by how much? Okay, changing y. Changing y by 3. -2, 12. All right. So we've discovered A, H, and K in function notation, how it's going to affect the graph. Now we're going to write it down. We'll formalize it together. Okay? Here we go. A. And I'm going to do it in order because order matters. First, you will do A. And we can match up the words, okay? And I'm going to change it to maybe like more function words as opposed to geometry words, even though they mean the same thing. So this is going to be stretch for being bigger, compress for being smaller, or reflect. But I'm going to be specific. Reflect over x axes. And I'll leave that link up so you can go in and you can slide these things around and guess and check and see what happens. Okay. Which coordinate does this change? X or Y? I think I heard it. Changes the Y coordinate. Delta, that's a triangle, means delta, which is change in Y. Remember that slope, change in Y over change in X, delta Y over delta X, okay? Changes the Y coordinate. Now, I've got two other things that are happening here. HK. Now, this maybe wasn't apparent on that screen. What direction did the H move the graph? H, which way did H go? Yes, okay, so it moved the graph left or right. Yes. Leave a spot. We have to say one more thing there. Okay? And we're gonna say K. Right? I like more space. There you go. K. Okay. K moved the graph up or down, which changes the Y coordinate. Notice we have two things that affect the Y and only one thing that affects the X. But we're missing something here. And I'm going to flip over to the Desmos graph and we're going to make some guesses about what we're missing. You can watch, you don't have to flip over. Okay, so let's put all of these things back. Okay, I'm just going to hide them, right? I'm going to click in a new one. Okay, f of x plus, it's going to graph as soon as I do this right. Where'd it go? Where'd it go? It moved left. Watch this. Do you see it? Want me to add some grouping symbols for what H is? Yeah, the formula's got a negative built in, which means what you're seeing is really the opposite number of what it is. You see a +2, but it's really opposite that. Right? You're like, oh yeah, I went left too. Okay. It really went left too. Really went left 4. Really goes left 5. Right 4. It's because, look, I'm putting parentheses around the H number. Compare it to your formula. The minus is already there. Minus +4. That means H is +4 and it's going right 4. That's what we're missing in our notes. So what do you say in your notes to remind you of that? Opposite. It's really opposite of what I see. Whew. Okay. Now let's actually try to do these transformations in our notes, right? We've got the function notation. Let's see if we can actually do it. Okay, so you should have some graphs in your paper. There's always more up here if you need them. If you care about the numbers being in order, look closely. Yeah, go for it. Help yourself to anything you need. Okay. Now at the very top of my page, we're just going to start the examples here. And we're going to, given the parent, we're going to call the parent f of x. It's only going to be 3 points. Okay, and I'm graphing it up here on purpose so that I can actually use my grids to draw. Okay, and I'm just gonna okay, so it's 3 points, 2 line segments. 3 points, 2 line segments. That's f of x. You don't need a grid, but I see some of you questioning. There you go. You don't need a grid. 3 points, 2 line segments. First example. Draw g of x equals f of x minus 2 minus 3. Okay, so now I'm giving it to you in function notation. And I've given you f of x up here, and we are going to draw g of x. But g of x is going to come from the parent f of x. Let's use our words. Right 2, because it's opposite, down 3. I'm going to write them in order. Right 2, down 3. As I'm learning, I'm going to make a little note to myself about which coordinate is changing. I am going to do it in a different color just to help me see what I'm doing. Okay. Okay. Now I'm ready. I've identified the transformation that I need to draw. Some of you might be visual. Some of you might not be visual. So we're going to do it 2 ways. I'm going to copy my parent onto this grid so that I can use it. Okay. And here's where I'm going to do my other color. Move the graph right 2, down 3. Right, you know how to translate from geometry. Move the graph right 2, down 3. You're just translating it. Move it right 2, down 3. How would I do that without a fancy clear sheet of paper? Just count your points. Move the dots and connect. Move the dots and connect. Right 2, down 3. Right 2, down 3. If there's a lot of dots, you might want to connect as you go so you don't mess up the order. Right 2, down 3. Notice that they still look parallel, that the both sections still look parallel because we didn't stretch or compress. It means the slopes didn't change. Okay, add the domain and range just as practice. You've learned characteristics. At any point I could ask for them. Where is it increasing? Where is it decreasing? Does it have an x-intercept? At any point those questions can reappear. I prefer interval notation. Notice that that's a continuous graph. Means it's an inequality. I did it in red because it's matching the red graph. And I might as well label in red, right? G of x is the one that's in red here. You can highlight them, right, if you want to differentiate. Okay, write down the new points. 0, 1, 2, 2, 5, negative 1. This is not just a how-to class, right? I will never just tell you how to do it. You're going to have to put some things with it. You tell me, how do I get from this table to this table? Don't look at the graph. How do I get from this table for f of x, that table g of x? Think about it. Share with the person next to you, or behind you, or in front of you. Yeah. I hear some really good answers. Who wants to share? Do you want to tell us? Yeah? All right, listen.
Since you know for the letter which coordinate you're changing, you would just add 2 to the x, and then you would subtract 2 from the y.
So in the change in x, I will change the x's by plus 2. Negative 2 plus 2 is 0. 0 plus 2 is 2. 3 plus 2 is 5. In the x's, because I'm changing x's. The y coordinates are minus 3. 4 minus 3 is 1. 5 minus 3 is 2. 2 minus 3 is negative 1. You can do this graphically, which I find easy. You can do it in the table, which is similarly easy. Sometimes questions will be easier one way or the other, or you have visual strengths or numerical strengths, but they are all connected. All right, let's do another one. Number 2. Draw, let's call it h of x this time. It just needs a new name. I can't call everything f of x. 2 times f of x minus 1. When you write your transformations in words, write them in the order that you're going to do them in. That way it's just a reminder. And I'm going to just copy my parent over, so for those visual learners, I've got a parent function to look at. Okay. In words, in order. Stretch y by 2. Stretch is for getting bigger. Down 1. All right. Stretch. Dilations are always harder than translations. Stretch y by 2. That's a change in the y coordinate. PEMDAS. Multiply comes before subtraction. In the graph, the y coordinate is 4. Now the y coordinate is 8. I did an open circle, right? I got 2 steps here. I did an open circle just as a placeholder. The y coordinate is 5. Now it is 10, which is just barely off the graph, sorry. The y coordinate is 2, and now it is 4. Right, I'm not done. I'm not done. Down 1. Stretch by 2, down 1. Take the dotted one and move it down 1. Not parallel anymore because you stretched it by 2. My slope went from 1/2 to 1. My slope went from -1 to -2. Doubled. The y coordinates doubled. Okay. Fill out the table, but don't look at your graph. Fill out the table, but don't look at your graph. Right? You got to be able to do all of it, okay? Play to your strengths, but also work on your weaknesses. If you're good at the graph, great. Make yourself try the table. Now, is there any changes on the x's? No. Then I'm just going to jot down my x's because they're not different. My x's aren't different, so I'm just going to copy them from the parent. And I'll just re-jot my parent table here so that we can look at it. -2, 0, 3, 4, 5, 2. Can anyone give me an idea of how I should move this table around to get to the new coordinates? Yeah?
So you take the 4 from the parent function, multiply by 2, and then subtract it.
Times it by 2. And I'll do it in 2 steps. Okay? The y coordinate has to be first times by 2. 8, 10, 4. You guys are all good at arithmetic. Okay? You can do that. Then I will subtract 1. Notice that I'm changing the y coordinate. I'm only looking at the y column. I'm just jotting my steps down next to it. 7, 9, 3. I'm going to highlight these. Look at the endpoints on your graph. Did I do it? Did we get it? Yeah. That's it. I just transformed my table instead of the visual diagram, but you get the same result. Do you have to show all of the steps? No. But should you be able to write a table or a graph? Yes. Okay. Last one. Draw, call it k of x, negative f of x plus 1 plus 2. All right, and table, start where you want, but you should be able to get both. Even if you cover up one of them, you should be able to get the other. Okay. Reflect over x axes. Left 1, up 1. Notice the opposite, left 1, the opposite. So I got a change in X, a change in Y, a change in Y. Two things are going to change the Y column. One thing is going to change the X column. The order matters. The reflection must occur before the left and the up. Now, left and up are add and subtract. Those can happen simultaneously. It doesn't matter which one you do first. Okay. How do you reflect? Well, you take your parent and you fold it over the x-axis. Here goes the fold. Oh, there it is. So what coordinate changed? The y-coordinate. And it went from being a positive 4 to a negative 4. Right? How do you fold it over the x-axis? Which coordinate is changing? The y-coordinate. It goes from the positive quadrants to the negative quadrants. So down to negative 4. And then you go left 1, up 2. All right. 2 phases. Reflect from positive 4 to negative 4, because I know that I'm changing the y-coordinate. From positive 2 to negative 2. It's dotted, it's open, because I know that I'm not all the way done yet. I do need to do this in 2 phases, at least until you get good at it. Okay, check. Left 1, up 1. Now connect. There's your graph. Oh, sorry, I went left 1, up 1. I meant to go left 1, up 2. So sorry, guys. Tell me when I do that. You know what's easier? Fewer changes. I accidentally wrote 1 and then moved it 1. I meant, it's fine, just make them all 1. Plus 1, up 1, up 1. Unless you did it right, just make it match. Did I? Yeah, we're okay? You got me? Okay. That's it for your notes. Congratulations, you made it.